Okay, folks, welcome back. Trigonometry, angles and ratios, lesson 3, applications of the reference angles and the cast rule. So this page actually is a nice summary page of everything so far, lesson 1 and 2 kind of combined. Quick overview. In this lesson, we're going to use our knowledge of rotation and reference angles and the cast rule to first determine exact trig ratios for angles between 0 and 360 degrees, given some terminal point or point on the terminal arm. And we're going to determine the trig ratios for a rotation angle from 0 to 360, given different trig ratios for the angle. So working backwards, okay? That's where we're going to have to use the reverse Pythagoras stuff. So what have we learned? We've learned that there are 4 different quadrants in our coordinate grid. We know how to draw rotation angles, which start on our initial arm, which is always the positive x-axis, rotates through to the terminal arm, always, always, always. And then whatever is left over to the nearest x-axis, that is our reference angle. And when we have numbers, we can determine those reference angles by, if we're in quadrant 1, rotation angle and reference angle are the same. In quadrant 2, rotation angle is equal to 180 degrees minus the reference angle. In quadrant 3, the rotation angle is equal to 180 degrees plus the reference angle. And in quadrant 4, the rotation angle is equal to 360 degrees minus the reference angle. And of course, if you have the rotation angle, you can work any of these backwards, right? Just by doing the reverse process. So if you have the rotation angle, then to find the reference angle, you're going to, you're just going to rearrange your formula. Let's say your rotation angle is 280 degrees. Let's erase this. So I have 280 degrees is equal to 360 minus my reference angle. Okay, so I'm going to first subtract 360. I'm sure you can all figure this out. 280 minus 360 is negative 80 is equal to negative rotation angle. So I divide by -1, divide by -1, that's 80 is my rotation angle. Okay, so you can figure it out, right, using some mental math or some quick processes. We also learned about the cast rule. This tells us all the positive values for our trig ratios, right? CAST, or you could use the other one, add sugar to coffee, either or, whichever one works best for you. We did also redefine our trig ratios using x, y, and r. Sine is y over r, cosine is x over r, tangent is y over x. An easy way to remember the sine one is sine is, or 7 yellow rabbits, so sine is y over r. That makes cosine the other one, which is x over r, and tangent is just y over x. Or you could actually write tangent. Tangent is sine over cosine, right? It's the same thing, which you're actually going to use later in this unit somewhere. So that's a nice summary page of everything so far. So if you flip the page, let's look at this example. Exact values of trig ratios given a point on a terminal arm. So example 1, point P -3,2 lies on the terminal arm of angle theta in standard position. Complete the following procedure to determine the primary trig ratios. So the point -3,2 might be over here somewhere. -3, 2. There's my angle. This would be my rotation angle. This is theta, my reference angle. I could draw my Pythagorean triangle right here. This would be 2, this would be -3. I don't know what r is yet. Sketch the rotation angle on the grid and mark the point P -3,2 on the terminal arm, which we did. Calculate the exact length of OP. So this is origin, O to P, which is our point here. Calculate the exact value of OP, which is r. So I go to my Pythagorean theorem, r squared is equal to x squared plus y squared. X was -3 squared plus 2 squared, which is 9, plus 4. R squared is equal to 13. So r is equal to square root 13, and we have to leave it there. exact value, no decimal places. Where does it say? Complete, calculate the exact length. So no decimal places, we leave it as a radical. Question C, use x is -3, y is 2, and r from above to write your three trig ratios. Sine theta is equal to y over r, which is equal to 2 over root 13. Now, I'm going to fill these in, and I got to come back and do one thing, because that's not finished. Cosine theta is equal to x over r, which was -3 over root 13. And tangent, I wrote so big. Tangent theta is equal to y over x, which is equal to -3 over 2. That one is done. But these two, this should be bugging you. 2 over root 13, -3 over root 13. This should be bugging you because in our previous unit, when we dealt with radicals, we did not leave answers with radicals in the denominator. Now, I believe that's a bit of a drawback in this book, because in this book, oh no, it looks like they've done it. It's the other book. There's a book that I've used in the past where it doesn't do this, but you have to. So because we have radicals in our denominator, we have to go through that process of getting rid of that radical in the denominator. And hopefully you remember that's called rationalizing the denominator. I'm going to multiply by root 13 over root 13. That's going to give me 2 root 13 over square root of 169, which is just 13. 2 root 13 over 13. That is my final answer for the sine of this angle. And I do the same for this one. Root 13 over root 13, -3 root 13 over square root of 169. Is it once? Yeah, 169, which is equal to -3 root 13 over 13. Final answer. Okay, so there's your three trig ratios. Example 2. Point -4, -2 lies on the terminal arm of angle theta in standard position. Determine the exact value of sine theta. So let's first of all draw our coordinate grid, plot our point, see what we're dealing with. -4, -2. -4, -2 may be over here somewhere. Oh, on the wrong page. I had my notes on the wrong page. I was wondering why it looked different. There's our angle, P, -4, -2. It says to determine the exact value of sine theta. Sine theta is y over r. Well, I don't have r, do I? So I have to figure out r. So this is the roundabout way where they get you to do all of the work by asking you one question. What is sine theta? Well, I need to figure out r first. R squared is equal to x squared plus y squared, -4 squared plus -2 squared, 16 plus 4, r squared is equal to 20, r is equal to the square root of 20, 20 simplifies to root 5. 2 root 5. So now I can go here, sine theta is equal to y, which is -2 over 2 root 5. But now I have some simplifying to do, and I need to rationalize my denominator. Okay, so first of all, the 2 and the 2, this will cancel. Now I have this, -1 over square root 5. Now I need to rationalize my denominator. Multiply by root 5 over root 5. That's going to give me negative square root 5 over square root 25. And that's going to be negative root 5 over 5. Done, finished, final answer. Okay. Over the page. I think I decided to do this lesson right now because it's pretty quick. Over the page, example number 3. Angle A terminates in the third quadrant with sine A equal -4/5. Complete the following procedure to determine the values of cos A and tangent A. So A, since sine A is -4/5, which is equal to y/r, we know that the point is x something, x is something, and -4. So I know that negative sign goes on the top because r has to be positive. R has to be positive, so the negative has to go on the top. Lies on the terminal arm in the third quadrant with r equal to 5. Sketch a diagram, draw the reference triangle, and mark x and y -4 and r 5. So somewhere I'm going to sketch so it's x and -4, so it's down here somewhere. X, -4. I know that my r value is 5, and my triangle looks like this. This is x, this is -4. Is that what they wanted? Yeah. Use Pythagorean theorem, x squared plus y is equal to r squared, to determine what that x value is. So we're doing reverse Pythagoras now. X squared plus y squared is equal to r squared. X squared, I don't know, plus -4 squared is equal to 5 squared. So I go x squared plus 16 is equal to 25. Subtract 16. X squared is equal to 9. Square root both sides. X equals 3. Okay, so x is equal to 3. It says note that in quadrant 3, the value of x must be negative. So of course, how did we end up in quadrant 3? Did I draw that in the wrong spot? Did I draw that in the wrong spot? Oh yeah, sorry, I missed it. Terminates in the third quadrant. That's not my diagram. Screaming and yelling at me because he knew I had it wrong. So it said it was in quadrant 3, so it should be here somewhere. This is x -4, 5. This does not exist. There's my triangle, x -4. Quadrant 3. My bad, sorry. So now here, because it is in quadrant 3, x has to be negative. So really, x is equal to -3. Use the values of x, y, and r to determine the exact values of cosine and tangent. Cosine theta is equal to x over r, which is equal to -3/5. Tangent of theta is y over x, which is -4/3, which is just +4/3, because a negative over a negative is a positive. There are your two other ratios. And we already knew sine because it kind of told us, right? -4/5. Example 4. See if I can do this one with no mistakes. If tangent theta is -2/3 and cosine theta is positive, find the exact value of sine theta. So here we go. Here's our coordinate grid. Let's use our cast rule. Whoops. So we need to determine where this point could possibly fall. Well, it can be -2, 3. So this is, remember, tangent is y over x. So our coordinate point from here can be 3, -2, or -3, 2, right? Y over X. So it can be -3, 2, it can be here, or 3, 2, it can be here. But it says that cosine theta is positive. And if we look at our cast rule, C-A-S-T, cosine is positive in quadrant 4, but cosine is negative in quadrant 3. So first of all, it can't be in quadrants 1 and 3, and it can't be in quadrant 2 because cosine is negative. So it can't be here. So our line or our angle has to go this way. Then find the exact value of sine theta. Well, I know that this is 3, this is -2, and sine theta is y over r when I don't have r yet. So now I have to find r. R squared is equal to 3 squared, -3 squared, nope, 3 squared, plus -2 squared, which is 9 plus 4, which is 13. R squared is 13. R is equal to square root 13. So filling in our y, which is -2, r is 13, square root 13, I now have to rationalize. Times by root 13 over root 13. This gives me -2 root 13 all over 13. There's your sine value. Okay, that takes us to the end of lesson 3. Checking Scholastic or the sideboard or whatever to figure out which questions need to be completed. And we'll see you next time.